Good morning, children. In the chapter Playing with Numbers, we are going to learn about different patterns in numbers, how and all the numbers look different and all those things. It's a very interesting chapter, and today we are going to deal about perfect numbers and prime and composite numbers. You have been only thinking about 1, 2, 3, 4, 5, but there are different names for different numbers. Let us see what it is. Perfect numbers. Today we'll be dealing with perfect numbers, children. Okay, so we'll move on to look at what is written here. A number for which the sum of all its factors is equal to twice the number is called a perfect number. That is, I'll read it once more. Listen carefully. A number for which the sum of all its factors is equal to twice the number. Twice means 2 times. That is multiple by 2. Multiply by 2. That is twice. Is equal to twice the number is called a perfect number. So now let us check numbers and let us see that what all factors those numbers have. Okay. So let us move on. Now let us see the factors of 6. You know how to write the factors of 6. The factors of 6 are 1, 2, 3 and 6. These are the factors of 6, children. Now, we are going to add up all these factors. What is written here? You see here, a number for which the sum of all its factors. So, we have to find the sum of all its factors. So, what are the sum here? The numbers are 1, 2, 3 and 6. So, we have to find the sum of all these things. Let us find the sum of all these things. How will you get the sum? Let us see. 1 plus 2 plus 3 plus 6. So, we have got 1 plus 2 plus 3 plus 6. That is equal to 12. And 12 can be written as 2 into 6. Are you following, children? Now you see here, our number is 6 and we are multiplying 6 by 2. Can you see this? Our number is 6 and we are multiplying 6 by 2. So this is what we said. We are multiplying it by 2. 2 means it is twice. 2 is what we call as twice. Twice means multiply by 2. So that is what is written here. Can you see? A number, we have taken a number 6, for which the sum of its factors, we have taken all the factors 1, 2, 3 and 6 and we have found the sum of its factors, sum has come as 12. And if it is equal to twice the number, if that 12 is equal to 2 times the number, yes, 12 is equal to 2 into 6, then that number is called a perfect number. Got it, children? Then the number is known as a perfect number. Now let us see. Is 6 a perfect number then? Is 6 a perfect number then? Yes, 6 is a perfect number. Why do you say 6 is a perfect number? Why do you say that 6 is a perfect number? Because when you add all the sum of its factors, then you get sum of the factors is equal to 2 times 6. So we can say 6 is a perfect number. 6 is a perfect number. Now let us see factors of 28. Now what are the factors of 28, children? The factors of 28 are, I told you how to write the factors. First we write 1. The last number is 28. 1 and 28. Then we start from, we know that 1 is a factor of 50 number and all the numbers are equal to or less than the number itself. All the factors are equal to or less than all the factors of a number will be equal to or less than the number itself. So we are writing all the numbers will be between 1 and 28. Now 2 if you take 2 and 14. 2 into 14 is 28. 3 is stable. 3 nines are 27. 3 tens are 30. 28 is not coming. Now 4 stable if you take 4 into 7. 4 sevens are 28. So 4 and 7 has come together. 4 sevens are 28. 5 stable. 28 does not come. 5 5s are 25. 5 6 are 30. 6 stable. 6 4s are 24. 6 5s are 30. So 28 doesn't come. Next number is 7. 7 is already here. So we have finished all the factors. Now we are adding the sum. 1 plus 2 plus 4 plus 7 plus 14 plus 28. The answer is 56. Now children, this 56, is it equal to 2 times 28? 2 into 28, will you get 26? Find out. 2 into 28, are you getting it as 56? Tell me, are you getting it as 56? Yes, this is equal to 2 into 58. You must have understood this is equal to 2 into 58. Now what do you say? Is 28 a perfect number? Yes, 28 is also a perfect number. Is also a perfect number. Understood? Yes. Now let us see 10. Is 10 a perfect number? Let us write 10. You can solve it on your own and you will have to tell me 10. What are the factors of 10? First one is 1, the last one is 10. Then next 2 and then 5. 2 5s are 10. All the factors are over. Sum. What do we get the sum? 1 plus 2 plus 5 plus 10. What do we get? 1 plus 2 is 3. 3 plus 5 is 8. 8 plus 10 is 18. Is it, now what is 2 into 10 children? 2 into 10 is equal to 20. Isn't it? So is 18 equal to 20? 18 is not equal to 2 into 10. So what can we say? 10 is not a perfect number. 10 is not a perfect number. Okay children, so you understood this as well. 10 is not a perfect number. This is about perfect numbers. Now we are moving on to prime and composite numbers. Let us see what are prime numbers and composite numbers. Observe the number of factors of a few numbers. Now as I say, you will tell me the factors. 1. What are the factors? Factors. We are going to write the factors. Factors of 1. That is 1 only. Then factors of 2. 1 comma 2. Factors of 3. 1 comma 3. Factors of 4. 1, 2 and 4. 1 into 4 is 4. 2 into 2 is 4. Factors of 5. That is 1 comma 5. Factors of 6. You'll get 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor. 1 into 6 is 6. 2 into 3 is 6. 7. 1 comma 7 only. 1 and 7 only. There are no other factors. 8. 1 and 8. Then you have 2 and 4. So 8 also we have written. What about 9? 1 and 9. And 3 into 3 is also 9. Isn't it? So 3 into 3 we need not write it 2 times. We'll write it only one time. 3. 1, 3 and 9 are the factors. What about 10? We have just now written 1, 2, 5 and 10 are the factors. Okay children. Now see here. For 1 we have only one factor. That is 1 itself. All other numbers, they have 2 or more factors. Okay, there is no other number which has only 1 as factor. Only one factor. All other numbers have more than 1 factors. Only 1 has got just 1 itself as factor. So 1 is very special. Okay, 1 is very special for us because it is very lonely. 1 is very lonely. 1 is standing all alone, or we can say he's perfect. Okay, because 1 any way you take, 1 is standing alone, doesn't need any support or anything. 1 is only standing alone. 1 is 1 only. So it is very special. All other numbers you see, they got, see here 2. They got 2 factors, 1 and 2. 3, 1 and 3. 5, 1 and 5. 7, 1 and 7. All these numbers have got 1 and the number itself as the factor. Can you see all these numbers? 1 is a factor. Children, here all the numbers have got 1 as a factor. Can you see that? All the numbers have got 1 as a factor. And what is the other number? What is the other number? The number itself. That is what I am telling you. The number itself is coming as a factor. See here, 1 is a factor here. All places, any number you take, 1 is a factor. Here also any number you take, 1 itself is a factor. Then any number you take the number itself. 2, 2 is a factor. 3, 3 is a factor. 5, 5 is a factor. 8, 8 is a factor. So here in this group where I have written, there are only two factors. That is 1 and the number itself. Here the 2 is the number is a factor. 3 is the number, 3 is a factor. So such numbers where we have only 1 and the number itself, then we call them as prime numbers. That is, in these cases you have only 1 and the number itself as factor. So we call these as prime numbers. Okay children. Now when you take this side, you have 1, 2, 3, 6, there are many. These numbers where they have more than two factors, we call it as composite numbers. They are known as composite numbers. So the thing is, prime numbers, it has got 1 and the number itself as factor, whereas in composite there are more than two factors. Okay. Now let us see. What is it? The numbers other than 1. Why other than 1? Because 1 has got, 1 is special. 1 has got only 1 as factor. The numbers other than 1 whose only factors are 1 and the number itself are called prime numbers. The numbers other than 1 whose only factors are 1 and the number itself are called prime numbers. Have you understood children? Yes. Now let's see. Let's move to the next slide. So we got the numbers other than 1 whose only factors are 1 and the number itself are called prime numbers. You understood what are prime numbers. Then what are composite numbers? Numbers having more than two factors are called composite numbers. Now can you tell me the examples children for prime numbers and composite numbers? What have we written as prime numbers? We got 2 is a prime number because 1 is a special number. We should not be writing it there. So 2 is a prime number because it has got 1 and 2 as factor. 3 is a prime number. 5 is a prime number. 7 is a prime number. Understood? These are the prime numbers we got. Numbers having more than factors. What are the numbers we got? 4. Then we got 6. Then we got 8. We got 9. We got 10. Understood? Now see here. These are the prime numbers. Which is the smallest prime number? From where are the prime numbers starting? Smallest prime number is 2. Smallest prime number is 2. And what is the smallest composite number? Smallest composite number is 4. Okay. Be very careful children. These are basic things that you should be remembering. Even in 10th standard when the question comes, smallest composite number, children just look up. Find the HCF of smallest composite number and smallest prime number when the question comes. The number is not given, how we'll find madam is the question. So you should know all these things. These are 6th standard is very much important, this chapter, basics. Okay. So smallest composite number is 4. Now what about 1 children? What do you know about 1? 1 is a special number. 1 is saying I am special. Why is it special? Because 1 has got only 1 as the factor. Therefore, 1 we cannot count as a prime number or as a composite number. This sentence you should learn by heart. 1 is neither prime nor composite. 1 is neither prime nor composite. Okay. Now we'll move on to erosionous sieve. This picture that I am showing you here is of Erosionus, a Greek philosopher. And you can see here, I have kept a picture also. That is the sieve. This we have in our kitchen, isn't it? Why do we use the sieve? To separate materials, isn't it? For tea. To separate the tea leaves and other things from the tea. So, this is a strainer or we call it as a sieve. So, Erosionus found a sieve. Now, what is the specialty of this sieve of Erosionus? Let us see. Erosionus sieve is special because it is used for sieving the numbers. Can you see children? When I put 1 into it, 1 is coming out of the sieve and staying. because I told you one is special. Now when I put 2 into the sieve, I'm showing you one by one. All the numbers together you put into the sieve and you sieve it. Now if 3 is going into the sieve, 3 will also come down. 4, it is not able to come out. It is stuck in the sieve. 5, that is also coming out through the sieve. 6 is also stuck there. Now from all those that I have discussed with you children, you tell me, what is the sieve about? You can see what are the numbers that has come out through the sieve. It is 2, 5, 3. What are these numbers? Does it ring a bell? In the earlier thing, what have you learned? 2, 5, 3 and all what numbers? Yes, they are all prime numbers. And 4 and 6. What are 4 and 6? 4 and 6 are composite numbers. And 1 is a special number. So 1 has stood out. 4 and 6 are staying in the sieve itself. 2, 5 and 3 has come down. Okay. So this sieve is for separating prime numbers and composite numbers. Okay. That is the specialty of erosionous sieve. Now, if you look at the spelling of erosionous, learn from your textbook. We pronounce it as erosionous sieve, but the spelling is slightly different. Open your textbook and learn the spelling. Okay. Now this is how we prepare the sieve, children. The numbers are there. And I want you to make this grid, 10 by 10 grid. This is the 10 by 10 grid. You have to make this 10 by 10 grid. And then you have to find out which are the prime numbers. Okay. Now, first I am going to start with 1. 1 is a special number, I know. So what am I going to do with 1? I'll just cross out 1 because I don't want 1 in this. I'm going to start with prime numbers and composite numbers, and so I don't want 1 in this. I'm just going to cross out 1. 1 is neither prime nor composite. So let's leave 1 alone. Now I'll start with 2. You know the multiplication table of 2? Yes. Tell me, what are the multiples of 2? Multiples of 2 are 4. So I'll cross out 4. Then I have 6. Then I have 8. Then I have 10. I have 12. 14. 16. 18. Can you see? It is very easy to cross out. 20. Can you see, children? Yes. And all these numbers, what we call them? All the numbers, multiples of 2, we have a name for them. All the multiples of 2 are known as even numbers. Okay? Even numbers. All the multiples of 2, they are even, E-V-E-N, even numbers. So, if I start marking it, the whole line will go off. Can you see? All this. You can see 2, 2, 2, 2 when you see. This is how the 2's multiplication tables will be coming. This whole thing is 2's multiplication table, what I am coloring. All these will come in 2's multiplication table. Okay. So this is how you should be doing. You take one color for 2 and then you cross out. Okay. You can color it neatly. I'm just crossing out to show you. So all the numbers, all these numbers are known as even numbers. They are all multiples of 2. So all these numbers, they come under composite numbers. So when I say multiples of 2 are all even numbers, then which is the only even number that is a prime? A prime number among this. Which is the prime number? All these what I am crossing out, they are all composite numbers. So which one is prime? Only 2 is the prime. So what do you get? 2 is the only even prime number. Only even prime number is 2. Any other prime number you take, any other number you take, a prime number, they'll all be odd numbers. They're not even, if it is not a multiple of 2, then it will be odd number. Okay. So 2 is the only even prime number. So any number given to you, if I am giving you 202 or if I am giving you 252, I am asking you whether it is prime or prime number or not, you need not worry. Just look at the last digit. That is unit place, which is 2. So when unit place is 2, unit places, you can see all these numbers here. All these numbers you see children here. The first line, the unit number is, what do you find? Units number is 2. Second line, the units number is 4. Third line, the units number is 6. Next units number is 8. Next units number is 0. So you see here 2, 4, 6, 8, 0. Any number ending in 2, 4, 6, 8 or 0, they will be composite number. So 252, the last number is 2. The last number is 2. So it is a composite number. Now if I write 786, if I write it as 786, then you tell me, if I write 786, the last digit is 6. You can see here, when the digit is ending in 6, they are all composite numbers. So this is also a composite number. It is an even number, therefore it is a composite number. Okay. Only even prime number is 2. Don't forget children, only even prime number is 2. Okay. Now the next number, we have cut all the numbers here. Next number we'll take which is not cut after 2. What is the next number that is not cut? Let us take 3 here. Okay. So I'm going to take 3. Can you see when I draw 3? Can you see? Yellow color it is not seen. So let me take it as green. Let us see. So I'm taking 3. The red is seen very clearly. Okay. Now we are going to cut the multiples of 3. Okay. So 3's multiplication table, you know what is 3's multiplication table? 3 ones are 3. 3 twos are 6. 6 is already cut here. I'll give green color also there. Then after 6, 1, 2, 3. Then this 9. If you don't know the multiplication table, just add 2, 3, 3 and go. Multiplication table should be known by now. 3 3s are 9. 4 3s are 12. 12 is already cut here. I'll give the green color also. When you are giving colors, you see half you can give as red and then half you can give as green. Or you leave it in one color. Once it is colored, you leave it. Okay. You can go to the next number. 13, 14, 15. Then 16, 17, 18 is already covered. Then next 3 numbers 1, 19, 20, 21. So the third number next is 21. So we'll cover 21. 21 plus 3, 24 covered. 24 plus 3, 27. Okay. 27 plus 3, 30 colored. 30 plus 3, 33. So I'll go for 33. Then 33 plus 3, that is 36 colored. Okay. 36 plus 3, 39. 39 plus 3, 42 is colored. 42 plus 3, 45. 45 plus 3, 48. It is colored. 48 plus 3, 51. So I'll come to 51. 51. 51 plus 3 is 54. It is already covered. 54 plus 3 is 57. 57 plus 3 is 60. 63 next. 60 plus 3 is 63. 63 plus 3 is 66. 66 plus 3, 69. 69 plus 3, 72. It is already covered. 72 plus 3, it is 75. Where is 75? Yeah, 75. 75 plus 3, 78 colored. 78, 81. Next number will be 81. 81 plus 3, 84 is colored. 84 plus 3, 87. 87 plus 3, 90 colored. 90 plus 3, 93. 93 plus 3, 96. It is colored. 96 plus 3, 99. So we have finished all the multiples of 3 here. Now let us take, what is the number left now? 2, 3, 4 is already colored. The next number is 5. So we'll take 5. I've taken blue. 5 you know very easily. All the 5's table, here it is there. 15. All the 5's table. 5, 10, 15, isn't it? 5, 10, 15, 20, 25, 30, 35, 40, 45. You know the table. So all these numbers will come for 5. So 5's table we have marked very fast. All the 5. Whatever comes under 5, that will come as 5's table. isn't it? So this is whole thing is 5's table. 5, 15, 25, 35, 45, 55. All this is 5's table. Here again 10, 20, 30, 40. All these are multiples of these two lines. Okay, these two lines 5 and this 10. These two are 5's multiple tables. So we have filled all the 5's multiple tables. Then what is the number left next? The number that is left next is our 7. Let us start with 7. Now I'll mark 7 here. I'm going to mark 7. Now 7, let us see the numbers. 7's table. 7 ones are 7, 7 twos are 14. Now 14 is already marked here. Now if you don't know the table, keep adding 7 and go. 7 plus 7, 14. 14 plus 7, 21. It is marked. 21 plus 7, 28. It is marked. 28 plus 7, 35. It is marked. 35 plus 7, 42. It is marked. 42 plus 7, 49. Okay, 49 is not marked. So we have to now mark 49. So let us mark 49. So here I'll mark 49. Now next, 49 plus 7. What is the answer? 49 plus 7? 56. It is marked. 56 plus 7? 63. It is marked. 63 plus 7? 70. It is marked. 70 plus 7? 77. Okay, 77 is not marked. So now we'll have to mark 77. So we'll mark 77. Now 77 plus 7, it is 84. 84 is marked. 84 plus 7, 91. So 91 is not marked. We have to mark 91 as well. Okay, so we are going to mark 91 as well. 91 plus 7, 98. 98 is already marked here. Okay, so 98 is already marked here. Then you have 98 plus 7, it is more than 100. So we have finished of 7 also. So the first line we have finished 2, 3, 5, 7. These are all our prime numbers. Okay, now whatever is left without marking, let us round all that is left without marking. Okay, I'm going to round all the numbers that is left without marking. That is, first one, it is a 2. 2 is left without marking. Then we have 3. Then we have 5. So I'll write here 2, 3, 5, 7. In the first line we have 2, 3, 5 and 7. In the second line we have 11, 13, 17 and 19. So here we have 11, 13, 17 and 19. In the third line we have 23 and 29. So here we have 23 and 29. Then fourth one we have 31, 37 over. So it is 31 and 37. Now the next one is 41. We have 41, we have 43 and we have 47. There are 3 numbers. So we have 41, 43 and 47. Now we have next one 53 and 59. So in the next column we have 53, 59. Now let us move to the last one. We have 61. We have 67. So we have 61, 67. And here in the last one we have here in the 70s column we have 71. Between 70 and 80 we have 71, 73 and 79. So here the prime numbers are 71, 73 and 79. Okay. The next 80 to 90 it is 83. Next number we have 83. Now you have 83 and 89. So in this group you have 83 and 89. And in the last group you have only 97. Okay. So here you have 83 and 89. And in the last group you have only 97. So you have to count how many numbers are there. That you will be doing on your own. You have to count how many prime numbers are there from 1 to 100. All these numbers you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I'm not counting. You count on your own and you find out how many prime numbers are there between 1 and 100. Then which are the prime numbers between 1 and 10? This is how you should be writing. Okay, number of prime numbers between 1 and 100 is equal to this much. Write all these prime numbers. Then you write number of prime numbers between 1 and 10. How many are there? 2, 3, 5, 7. That is why I have written in each rows, children. Between 1 and 10 you have 2, 3, 5 and 7. Between 10 and 20 you have 11, 13 and 11, 13, 17 and 19. Now, in each column you see here you have only between 20 and 30 you have only 2. Between 30 and 40 you have only 2. Between 40 and 50 you have 3. 41, 43 and 47. So like this it will be easier for you to learn. Okay, next class I'll be asking you to say the prime numbers between 70 and 80. I'll call each one of you and I'll be asking you. Okay, don't worry about that. Each one will get a chance. Next, the last column you see, there is only one. Between 90 and 100 there is only one number, that is 97. Okay, so you can see here 91, 92, 93, 94, 95, 96, 97, 98, 99 and 100. Okay, so among these you see starting from 90. 90 is a composite number, 91 is a composite number, 92, 93, 94, 95, 96. This is the longest. Anywhere in between you cannot see so many composite numbers coming in between two prime numbers. Okay, so here you see 42 is the only composite number between two prime numbers. Here 53 and 59 you have 3 plus 2, 5 composite numbers in between. But between 89 and 97, how many composite numbers are there? 1, 2, 3, 4, 5, 6, 7 composite numbers. Okay, these are all the things you should be learning using this erosion sieve. This is the assignment given to you. So do this in a A4 sheet paper and then you have to submit it. Assignment I have uploaded. So you have to do this, color it beautifully, do it neatly, then write down all the prime numbers between 1 and 10, between 10 and 20, between 20 and 30, and then there are certain questions that I have given you. Do that as well. Okay, children. So have a nice day. That's all for today.